Welcome back to LeetCode Path to Pro. It's been like a week and a half. Been busy with schoolwork and then working on a personal project, updating the resume a little bit. But yeah, back at it, and I'm going to be doing Blind 75. So I have that list here. Blind 75 is just kind of a good, pretty comprehensive, like um, list of LeetCode problems. That cover a lot of the different patterns you'll see, right? He's got array problems, problems of binary, which, I guess I'll be learning kind of for the first time. Some DP problems, graphs, intervals, linked lists, matrix, string, a lot of tree problems, some heaps. So yeah, pretty stoked. Let's give it a. We'll start with Tucson, which I think I've done this problem so many times. I think on this channel as well. Let's see. What is this book? Oh, yeah, this is. Yeah, that book. Yeah, sorry. Just getting a little organized. It's been a minute since I've done something like this. What's in here? This is like my fancy LeetCode book. Yeah, okay. Bet. And then this is just for interview stuff. Cool. So maybe pretty good. Maybe we'll do it this year, I guess. Yeah. So I'm not gonna really write anything for this one. But yeah, this is LeetCode number 1, two-sum. It's an easy, and it's an array type problem. So we're given. Let me turn down the music a little bit. Not really vibing with this. So we'll just. Yep. All right. So we are given an array of integers nums and an integer target. We want to return indices of the two numbers such that they add up to target. And you're allowed to assume that there's one solution and you can't use the same element twice. So we want to return the answer in any order. So you can do this problem a couple different ways. The way I like to do it, originally, like the most intuitive way for me was doing 2 pointers. But I think if you're doing 2-pointer solution, you kind of run into, it's a little bit slower time complexity. I think you save some space complexity. And then it's also there's a more complex solution to implement overall. So yeah. So let's see. So we got our nums. So the other way you can do this is with a hash map or a dictionary. So we'll have like values dictionary. We're going to loop through for n in nums. And we want to look for the target. So or we'll find the difference. Difference equals target. Because, right, we can assume target's going to be greater than nums. In the case of something you want to return, right? In this case, obviously, these numbers 11, 15, but we don't. That's not something that adds up to target. We're not really concerned with that. Then we just check if diff in values. Then we will want to return a list. Just going to do it like this, return. Return indices. Well, like this. Right. We'll return I, and then the other thing we'll return is values of diff. Right. Else we are going to diff I, or sorry, values. So not showing anything. So let's see what's going on. So, I guess I'll do it here. So we got nums. Let's do this one. 3, 2, and 4. Target is 6. So we're looping through far and range. Diff equals target 6 minus nums of I, which is 3. So diff is 3 right here. And then we have our values. Dictionary. Maybe I'll put it here. Just looks like this. It's not, diff's not in values. So we're saying the key is going to be the index, so 0, 3. What we want because that check, I think, checks. Okay, I think I see the issue. So we want to store. So if we do it like this, that'll get the same thing. If difference in values, return I. I guess what we have to do is this. return the index value we're at, and then we want to set this is the key and the index, and we would like to return values of diff. Sorry. Sweet. Very good. Yeah. It's been like a month since I did this problem. So cool. So memory. Why is this one so much faster? If you need none of that. Yeah, doing the same thing. So basically what we're doing is we have our values. I was just, the first time I was storing the index as the key. What we want to do is store the value, or the like number in nums as the key, and the value should be the index, right? That's what we're doing here. Because then it makes this like if, so we can check if this difference has already been found as we've looped through nums. Makes it a lot easier to check for that. So yeah, so the time complexity of this, I think, yeah, so this is the same speed. Just kind of, you know, the space complexity is O of n, where n is the length of nums, the number of things in nums, because theoretically our dictionary could be the length of nums. So space easy. Time, I think, is also just O of n. Yeah. Hash map enumerate. O of n, yes. So we'll just copy and paste all this. It's a pretty simple problem. It's definitely kind of tricky though. You have to be a little bit careful with tricky with what you're storing in your hash map or your dictionary. So okay. So now let's do best time to buy and sell stock. Have I ever done this? Yeah. Ooh, long time ago. Okay, bet this is a good one. So we are given an array, prices, where prices of I is the price of a given stock on the ith day. Let's maximize your profit by choosing a single day. By choosing a single day to buy one stock and choosing a different day in the future to sell that stock. I'm trying to maximize. Oh, interesting. So prices buy on day 2. Oh, interesting. I mean, I'm thinking. I'm just thinking, right, you could do this with 2-pointer. So we have our P prices array. 7, 1, 5, 3, 6, 4. Very nice. And I'm trying to think. Like, I feel like there's some complex ways to do this, but I feel like there's a really easy way that I'm just not thinking about. I mean, you could just store the max and just update the max, right? Like, oh, I'm trying to think. If you do like 2-pointer, right, where you have um, pointer here, pointer here. Well, do it here. Because that'd be element squared, right? I mean, so that's my just kind of brute force way of thinking about this, where we have a left and a right pointer. Or, I mean, I guess you could call it, it'd probably make more sense to call it by cell. Yes. That's fire. BS. And we just say, okay, we're buying at 7. Then we send our S out. So it's like 2 for loops. Send our S out. And just keep track of a max. And then just return whatever the max is at the end. Right? Because this will cover. And then once S has gone out and we've done the necessary calculations, we just increment both to here. So that's like the brute force way. I'm just trying to think if there's a better way that you could do this. I mean, right. It's tricky. So we have our like max. I'm just gonna go ahead and code that. I mean, like if you use the hash. Yeah, I don't know. Maybe. Yeah, I mean, I'm just gonna code that up. So we have like. We could call this like. I guess we'll call this B by and then for cell and range by yeah. Equals the max of max or prices buy minus prices of sell. And then we just return max. So it doesn't work. Is it just always return 6? I'm missing something. For buy, for sell and range buy, like the prices. So now we'll go through to sell. So buy is 7 minus 1 is 6. Oh, it's prices of sell minus buy. That's right. Very nice. Very nice. Yeah, like I said though, this is an O of n squared times complexity. Ooh, that looks like it doesn't even times out. Interesting, yeah. So this is too slow for something like this, right? Oh man, yeah, I mean, look at that. That's a brutal. I wonder if could you do binary search? How could we keep track? Binary search. I mean, I feel like that doesn't make sense because we want to. I mean, the other way I'm thinking maybe is like you could do. You could do something like keep track of a high and a low for buy and sell as you move through. Like, that's basically the same. Yeah, let's see. Let's try to see what we can get going here. So for index price, we have like a high, right? Something like that. And we need the high to be we want to buy, or we want to sell high, buy low. Alright, so a couple checks, like if sell high, price is greater than and get the hash map. So we could store the index. Right, like price. I want to look at the solution for February. So yeah. How does this work? Oh jeez, what was I doing here? So this is a two-pointer approach. See if we can figure out what's going on here. Interesting. Let's see. 6. And then let's see how long that takes. And then we'll try to implement ourselves. Yeah. So, okay, this is the same time complexity. So let's try to do this. I mean, this one makes more sense. Alright, so what's happening here? Let's see. So we're setting a min price, which is price to 0. So min, we're setting that to 7. Right, and we're setting our max to 0. Then we're looping through prices. So this is array slicing, and this just means it's like array slicing goes like this. So we have our array. This is like start of the array, where we stop. I'm gonna do all S's, and then step, like how big of steps we're taking. So here, right, we're starting at the first index. So we're gonna start here, and we're just gonna go to the end because they don't specify anymore. But that's just kind of the syntax. We are setting max profit to be the max between itself. So we'll have a max P here. And the price minus min price. So if we're at here, this is where our price is. 1 minus the min price is -6. 0 is bigger than -6, so we'll stick with that. And that's good because, right, on some of these problems we're going to return 0, right? Or we don't. Doing any transaction would put us in the red, so we don't want to do a transaction. So for here, we're going to do min price, and then we're going to check min price, update that. Min price equals the minimum of min price, which is 7, or the price we're at, which is 1. So min P actually, this is min P, sorry. Oh, that's max profit, sorry. So these 2 pointers, yeah. Or 2, and then, so min will get updated to 1, right? And we looped again. So now we're checking max profit, all right? Max P is the max of 0, which is what it is currently, or the price, 5, minus the minimum price, which is 1. 5 minus 1 is 4. 4 is definitely greater than 0, so boom, updated. Min price equals the min this of 1, and itself 1, and 5. 1's still smaller, stick with 1. Yes, I mean, min price will stay 1 the whole time. So we'll be good to go on that. Wow. Fantastic. So, I mean, this should be O of 1 space, right? I mean, we're not using any extra space. And it should be O of n. With, like, time complexity of max functions. So yeah, it is O of 1, max and min. Because basically the list that we're checking is 2 items. So it's a fixed size list that we're doing the max and min functions on. Yeah, I mean, this is O of n time. O of 1 space. This is pretty good. in my solution, the issue was this is also O in space, but it's O(n) squared time. And as you can see, for a very big input case like this, right here. Oh my gosh, this is huge, Um, quite a bit of scrolling. Just running out of time. It's too slow. So, yeah, pretty cool. There's this one that took a while. Yeah, some weird wild stuff. Oh, place to the left. I don't know. I'd have to look at 0. Yeah, so we just go until the end. If price of L is less than price of R. Right. Else, empty is right. Shocked that that works. Oh, because if it is, like, in the situation right here, it's less than, we get the max profit. We don't do the else, L equals R. Just increment R plus spin. We just keep going. Interesting. Yeah, that's an interesting way. I think this is a little more straightforward. Makes more sense, but so yeah, this is pattern. This is, I'd say it's like 2-pointer. Hash map. Solution. Keep track of max profit and min price. Zero min max P equals 0, min P equals prices 0. Loop prices. I mean, you could do that a few different ways. Like, right, we could do it like for price of prices. You do it like this. Well, I guess that is the best way. So you could do range. I mean, if we did range, we'd have to do some other stuff in here. It would just be like, prices of price. Prices of whatever index. Yeah. Okay. Yeah. So this is O(n) of 1. And complete. Say nah. Okay, so on to the next. Continues duplicate. Awesome. Oy. Keep the shirt. Let's see. So I assume I've done this problem, yeah. My son. So we are given an integer array of nums. Return true if any value appears at least twice in the array. Return false. Sick. So this problem is super easy. We could probably do something like this, where we have like nums. or what if we could do this? We could do like return if set else false. It's like speed run. Ah. Oh. Oh. Sorry. False. Return false. What? Give me an integer array nums, return true. Any value. Why is this return? Let's try that. What? Okay, so it's not that easy, but you get the point. Yeah, so yeah, I mean, we could do this with a set. A pretty easy way to do it. We could do scene set, and we say for n in nums. And basically, set is a data type. It's an abstract data type, and it is generally implemented with let's see. Let's see what there is. The abstract data type stores unique immutable values with no particular order, usually implemented with a hash set or tree set. Few sets are sorted, but so it's probably going to be a hash map. And when we're talking about Python, yeah, Python hash map, hash table, they're a dictionary, they're all the same. So hash set implemented using a hash map, it's the same. Yeah. So we do something like this, where if in scene, what are we doing? If it's return true, else scene.add I'm just gonna add end to that. If we get through all that, we don't see anything. False. Fantastico. You gotta assume that's pretty good solution. Yeah. Oh, what are these? It seems like it's a little bit less space. Same exact. And then here's just got a nice little check. Right, obviously if it's less than 1, the number of elements or number of values, we're going to return false because we're returning true if there's a duplicate value. But yeah, set makes it easy. We could also do this with like a hash map or a dictionary, So if n in scene, we want to say scene n plus 1. So basically here we have a dictionary where the key is the numbers, the values, and then our value is, so our key is the numbers in nums, and then the value is the number of times we've seen that. So, and now we need to check. We could just loop through for you could just do the same thing where you return true. I think. Let me just try. Yeah, so that works the same way. But if you want to and it's not as good, but we're just messing around. And then we could loop through. So for key value in seeing items, and this is just how we loop through dictionary. If value is greater than 1, we want to return true. That should work as well. Interesting, it's about the same speed though. So let's go back to the more ideal solution. Oh, it's so annoying. So then the runtime of this pretty good. Use a bit less memory as well, you can see. Although theoretically should be the same amount of memory. In practice it's probably less because we're looping through everything in this case. But in this case, we're going to return true in, however many test cases. And so that means we're not going to loop through everything. We're not going to add everything to our set. It'll help the time complexity and space complexity, during actual runtime, but in terms of O of n time, it doesn't change anything. So I guess we could say set. Use a set the This, I mean, it's a really simple problem. Set return false, return true. Duplicate values. So this should be O then, O then. Yeah. Cool. 3 easy problems done. Nice. Here we go. First medium. I think. Pretty sure I've done this. Yeah, I think I know this one. And I'm sleepy. Ugh. Take a little breather. Alright. Here we go. First hour done. I'm trying to do, almost first hour. Sorry, 3:04, I think. I'm trying to get like 2 hours, do 2-hour video every day of this. And on top of that, I'll be doing some just studying and then whatever else prep, in the school, and then also, applying for jobs and doing OAs and interviews and stuff. I've done quite a few OAs, kind of, and a couple interviews. I'm waiting to hear back. Yeah, it's an update, I guess. All right, so we are looking at 238, product of array except self, and I'm gonna change this. A little bit. It's kind of whack. Here we go. So product of array except self, given an integer array nums. Another integer array nums. Can you believe it? We want to return an array answer such that answer of I is equal to product of all the elements of nums except nums of I. Okay. Yeah. Okay. So this is this problem uses prefix, postfix, sum. So I'm just gonna go ahead and fill that out. So that's I guess you describe that as a algorithm type, and so let's see. I watched the NeetCode video on this. Shout out NeetCode as always. Dude's a stud. Yeah, so we got, and I think this is the example used in the video. I vaguely remember. So we got this, right? And we want our prefix. right? How are we gonna do it? I mean, we'll do something like this. Our prefix list can probably be empty. Postfix, though. Oh, actually, prefix should probably be like one. Like nums. Similarly, postfix. Right, so if we need to fill up our prefix array, we should move this a little bit. So, right. I'm just gonna think about it for a second. Prefix. Could we do it like this, where we say for n nums, and then we say prefix like this? Prefix. Prefix of index. What's that going to give us? And then at the end, we'll just like return false. Or we'll return a blank. What is that giving? I think I know that with this. Yeah. So I mean, that's kind of average building numbers, right? We need to multiply everything before. So okay, I think I have an idea. So if we do something like this, then we do for something like for j equals I, and for j in range start at 0 and go to I. What we want to do here now is prefix of I equals n. Right, because what this is going to do, we got our prefix, it's all ones. Right, we don't want it to set it to 0, because that'll just, for finding the products, for finding the sum, we set it to 0. So we have I, right, and we have j. And so we're going to do for I, we want prefix of I, because j is going to be 0 to I, equals n. Can you do times equals? Okay, so that's what we want to do. So we'll multiply by times j. Let's see if we get it there. Shout out closer. Okay, so this is what we want. So we gotta make sure. So if 1126, which if we do the prefix, so for 4, 1 times 2 times 3 is 6. 3, 2 times 1 is 2. 2, 1, 1. Let's get this. So I think we've achieved what we need to achieve with this prefix. So, cool. So hash that out for now. So now we have our prefix created properly. Right? It's 1, 1, 2. Right? Because if we look at this, 1 prefix sum of 1 is, there's nothing ahead of 1, so it's 1. It's really 0, but because we're doing multiplication, we can't set it to 0 because then it'll just stay 0, so we have to set it to 1. For 2, the prefix sum of 1 is, or prefix product, sorry. That's what it is. The prefix product of 2 is, there's only one thing that comes before 2, it's 1, so it's 1. Prefix product of 3, there's 2 things that come before 3, we multiply them, 2 times 1 is 2, so we get 2. Prefix sum of 4 is 3 times 2 times 1 is 6. And if you'll notice, the output here stays 6 because what's the postfix sum of 4? It's nothing past 4, so we're done. We're done with that calculation. So something, do we need to go backwards? I think we want to go backwards. So for I range, So we're going to start at the last element, go backwards only one. And we need j to be in range of, it could be I to blank those. I. So this is the postfix operation. I think we're doing a similar thing. And let's try. Let's see if this works. So let's see what's cool. Why is everything going to 6? Right. So now we have this. So starting I here. I's here. For J in range I. I mean, do we want to start it at we want to stop it at I. Backwards. What? Oh, oh, please. Damn. Fucking it up somewhere. Oh, maybe because we're printing. It's probably because we're printing. I bet that's why. Apparently not. I think that's frustrating. God, why do they keep doing this? I guess probably mostly code problems just have a time check kind of test case, which is some massive beast of a test case like this. Alright, well, let's still kind of want to walk through and see what's happening. So, we have I here. Yeah, we want J. Starts out here. Goes to I. Backwards. So nothing could happen there. Okay, move this over. Alright, whatever. Let's get to it. So now I is here. right. So now something more interesting happens. And then let's just get these up on the screen again. So now J pops in. Boom, J's here. Right? Starting at the back, stopping at I. Non-inclusive, we don't want to include it, but right, and we're multiplying prefix of I times into J, which is 4, so we get 8. I mean, yes, this is working correctly. It's just too slow. Just too slow. How could we speed this up? Can we speed this guy up? Yeah, I mean, I guess. Yeah, this is over in space. So we're satisfying the follow-up. Yeah, let's see what we're doing differently. You're releasing. Oh, that's okay. So just doing it a little differently. It's quite a bit quicker. So similarly, we have our, just call this prefix. Prefix equals 1. Oh, that's so smart. And then they're just summing. Answer of I equals prefix. Right, so I is here. And so I equals whatever our prefix is, which is 1. Prefix times equals 1, so 1. So this also becomes 1. And then multiply it. Now prefix becomes 2. We hit this becomes 2, which is correct. And then multiply it by whatever it's at. 3 times 2 is 6. This becomes 6. It's so smart. Then we set postfix equal to 1. And then you just loop backwards. Answer by. But now we're just multiplying it by the postfix. Brilliant. 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 Problem with my solution is like this is O of n squared, right? And mine was like O of n cubed. Yeah, this is a little bit better. So we're not doing the extra J. It's really smart. Yeah. O of n cubed. Bad. It wouldn't even. I wish it would like just do it. But yeah, honestly, like pretty close to solving that. I'll say no, but pretty close to solving that. I'm honestly pretty happy with that. And it only took like 20 minutes, so that's pretty good speed. I think like shooting for around 20 minutes for completing a problem is pretty good. So we want to answers array, just like this, times length of nums, and then we want prefix equals 1, set answers, prefix 1, loop through nums, answers I equals prefix. That's so cool that you can do this. Equals I, and then we have our post. Easy. Postfix equals 1. Answers loop backwards, right? As I times equals postfix, and then this is basically the whole code. Cool. So yeah, this is O n squared time space. I mean, in reality, it's like O of n minus 1 squared time, but that, you know, that's a constant. We don't care about that. We don't worry about that. So, yeah. Let's see. What's next? This is like good stamina training for problems too, because it's like, I mean, I'm extra tired today, but it is like good, forces you to stay focused. And, cool. Maybe we can get through one, maybe two more. We'll see how quickly we can get through this maximum subarray. It all comes down to this guy. Right. So. Turn it up a little bit, you know what I'm saying? This is a medium. Are you sure? Ah. And this is a different problem. There's also a medium. Woohoo! So, yeah, maybe just one more problem today. So we're given an integer array nums, find the subarray with the largest sum, and return its sum. Have I done this? I have, and look at that. It was a battle. So we're given an integer array nums. Once again, these integer arrays, fantastic. It's awesome. Excuse me. So I mean, this is pretty horrendous. Let's cut out some of that garbage and start. Let me start with this. So wait a little bit too long. Yeah, so I feel like this is going to be a similar type of solution to best time to buy and sell stock, right? We're going to use sliding window. This is a sliding window type problem. I feel like this is a sliding window. Not 100% sure, but so that's another algorithm. Let me think. Let me look that up. We could. Oh wait, I bet if I look at Dane's algorithm. Ooh. Interesting. Oh, I've never heard of this. Hmm. Let's look up how Nico tells us. I bet he does sliding window. I just hope somebody does sliding window. So this is not sliding window. Is. That works? Wait, is that what I see? It is. Interesting. Huh. That's pretty cool. That's a very good solution. Let's try using Cadene's algorithm. I've never heard of that. Let's look that up. That's pretty sweet. I mean, this is Oven. And this is a good problem because, right, as you saw, like the brute force is, Oven squared. So that's pretty rough. All right, where's Nick White? Like Nick White. So fun. Yeah. So funny. Java. Let's see this. I'm really loving either of those expressions. Interesting. Let's see. I want to see if this is similar. He's really good. That's. I don't really like doing that. Kind of confuses. I think it confuses. So do it like that. Start iterating for the second one. For each element array I am doing. So we want to iterate for n similar to how we, very similar to how we did this for buy and sell stocks, right? Update max current is the maximum of the current. Oh, they gave me fire. Let's just change this to nums I. So we're seeing if this is just greater than. Wait, that's what you do. Interesting. So this is assuming our max current could drop below 0. Interesting. Yeah. The key idea behind containment algorithm is the observation that the maximum separation element I. Interesting. And then we just return. Change. No. Change. And just return max global. Like this. Oh, just took a screenshot. Let me do that. This is similar. These are pretty similar solutions. Oops. Oopsie. Oh. Right. Wow. Wow, that's pretty cool. It's a little bit slower though. I wonder if that's just random. Space is pretty much identical. Yeah, so that's just random. Interesting. That's pretty cool. Alright, I like that. Contains algorithm. And I feel like that's probably what, if you get asked this question, that's probably what they're looking for you to know. Versus, I mean, that other problem is very similar, but this is the other solution. Yeah, this is O(n). So, current sum max current or 0. Max. Let's call it global. As we call it. I guess just Back sub. Back sub array. No. Submissive. And then loop through array. Starting at 1. Select 1 indexed. And then